Okay, so today we're going to talk about graphing polynomial functions and end behaviors of polynomial functions. So we're going to talk about the difference between a monomial all the way up to a trinomial first. So a monomial is an expression that is either a number, a variable, or the product of a number and one or more variables. So these are examples: 6, 2x, y squared. Even though this has multiple variables, this is still considered a monomial because it's one specific term. Now, a polynomial is a monomial or sum of monomials. So the monomials that make up the polynomial are called terms of the polynomial. So x squared plus 2xy plus y squared minus 4 is one big polynomial. Now, you could also have a binomial, which is just two terms, x plus 4 or 2x squared minus 6x, or you could have a trinomial, which is three terms. For all polynomials, the exponents must be whole numbers, and the coefficients are all real numbers. A polynomial cannot have a variable in the denominator. If it's got a variable in the denominator, it's not a polynomial. And the variables cannot be exponents. So a polynomial in standard form is written in descending order of the exponents of the variable. We talked about that when we were adding and subtracting and multiplying polynomials. So standard form just goes from highest exponent down to the constant. We're going to talk about the degree of a polynomial, which is the degree of the monomial with the greatest degree, the greatest exponent. Okay, so if it's a first degree, it's linear, second degree is quadratic, third degree is cubic, fourth degree is quartic, and fifth degree is quintic. So if you are given a polynomial and it asks for the degree, when there's only one variable in the polynomial, the highest exponent is the degree of the polynomial. When there is more than one variable, the degree of the polynomial is the greatest sum of the exponents. So if I'm looking at this first example, I have 4x squared plus x minus 7. Well, that's just one variable in that polynomial. So this term is the second degree, this term is a first degree, and this is technically the constant, which is a 0 degree. So the highest exponent makes it a second degree polynomial. Okay? If I take 3x squared plus x squared y squared minus y to the third power, this is a second degree. I've got two variables here, so I'm going to add them. 2 and 2 is going to give me a fourth degree, and then y to the third is a third degree. So my highest degree there makes that polynomial a fourth degree polynomial. So here, if I looked negative 2, x to the fourth, y to the third, z, if I add 4, 3, and a 1, that's going to give me, that entire thing is going to be 8th degree. 5x y squared z is going to be a 4th degree. And negative 6 x squared y squared z to the third is going to be a 7th degree. So my highest sum makes this an 8th degree polynomial. Okay? Now, this next section, we are going to be using direct substitution to evaluate a polynomial function. You're just going to follow your order of operations. So I'm going to give you a function, and I want you to evaluate it with this specific value. So if I have f of x equals 2x to the fourth minus 5x cubed minus 4x plus 8, I want to know what that is when x is equal to 3. I'm going to find the value of the function at x equals, not negative 3, positive 3. Okay, so all I do is plug that in. 2 times 3 to the fourth minus 5 times 3 to the third minus 4 times 3 plus 8. And yes, I want to see you plug that value in. Okay, from there, I understand you can type that in. F of 3 is equal to, when you type it in, you should get 23. So at least show me where you're plugging it in, then you can just type all of that in your calculator and get the value. So when x is equal to 3, the function is equal to 23. Now, end behaviors. Okay? The end behavior of a function's growth is the behavior of the graph as x approaches positive infinity or negative infinity. For the graph of a polynomial function, the end behavior is determined by the function's degree and the sign of its leading coefficient. Okay, so we kind of did that last unit when we did the quadratic inequalities, when we looked at the coefficient, and I told you all that it determined the right end behavior. So we're going to look at end behaviors now. Now here, I've got a quadratic function, y equals ax squared. Okay, my degree for a quadratic is 2, so it's even. Okay, the degree is 2, which makes it even. On your worksheet, you're going to have to identify what the degree is. So that means, is it even or is it odd? If it's even, then that determines, you'll notice a pattern, even versus odd, which I'll explain that in a minute. But, so here we have an even degree, and our coefficient, our leading coefficient, is positive. So every single time you have to describe the end behavior, we're going to describe what happens to f of x and where does it approach as x approaches negative infinity, and then we're going to talk about what happens to our function and what does it approach as x approaches positive infinity. So what does that even mean? So really what we're looking at is, what is the end behavior on the left side of my graph? And that's what this negative infinity is. And then what happens to my graph on the right, which is when x is going to positive infinity. So pretty much this is my template for end behaviors. So I want to see what happens to my graph as x approaches negative infinity. So as it goes to the left, for this quadratic function with a positive leading coefficient, it's going to positive infinity. It's going up, so it's going to positive infinity. Now, as I go to the right, my graph is also going up, so it's also going to positive infinity. So my function approaches positive infinity as x approaches negative infinity, as in my function is going up as it goes left. My function approaches positive infinity as x approaches positive infinity, as in it goes up as it goes to the right. So pretty much, if you think about it, this is your template. The only thing that's going to change is this right here. I'm always going to write as x goes to negative infinity and as x approaches positive infinity. I'm going to do it in that order, so I'm always going to do left, then right. Okay, so that would be my end behavior for the quadratic function with a positive leading coefficient. Okay, well, what's the difference between y equals ax squared and y equals negative ax squared? My degree is still even because it's a 2, it's still quadratic, but now I have a negative leading coefficient, so that means it's going to open down. So we're going to look at the end behavior. What happens to my function? Where does it approach as x approaches negative infinity? And where does it approach as x approaches positive infinity? So what happens to the left? Well, if it opens down, it's going to negative infinity. And even on the right side, because it's symmetric, the left is going down, the right is going down, so that's also going to negative infinity. So for a positive leading coefficient and an even degree for this quadratic, they're going the same direction. So as x goes to negative infinity and as x approaches positive infinity, they're both going to positive infinity. Whereas when it opens down, they're both going to go to negative infinity. Okay, but again, the degree and the sign of the leading coefficient is going to determine what happens there. And you're going to have to know this because you're going to have to, I'm going to give you a function without the graph, and you're going to have to know those two aspects and what happens. Okay, so that's quadratic. We're going to look at cubic, quartic, and quintic. Okay, so if you flip it over, you've got a cubic function. Well, a cubic is y equals ax to the third power, so that degree is odd. So again, if I ask you to describe the degree, I'm not asking you to give me a number. I'm asking you to tell me, is it odd or is it even? So here, the degree is odd. So my template, my function approaches, I'm going to leave it blank, as x approaches negative infinity. So I always look at my left side. Then we're going to talk about what happens to the function and where does it approach as x approaches positive infinity. Okay? Well, if I'm looking to the left, what happens? I'm going down, so I'm going to negative infinity. When I go to the right, it goes up, it goes to positive infinity. So for an odd degree, this is cubic, so it's odd, and it's a positive leading coefficient. So remember, if you think back to last unit, I told you the leading coefficient determines the right end behavior. Well, this right end behavior is going to positive infinity, and this leading coefficient is positive. Well, if it's an odd degree, they go in opposite directions. So if it's an even degree, they go in the same direction. If it's an odd degree, they go in opposite directions, and the right side goes in the direction of the sign of the leading coefficient. Okay? So if I look at my y equals negative ax to the third power, if I can identify that my degree is odd, I'm going to look at my leading coefficient. I have a negative leading coefficient. So that means the right side, since it determines my right end behavior, my right sides should be going to negative infinity. So if I look, my function is going to approach positive infinity as x approaches negative infinity, meaning as it goes left, it goes to positive infinity. And then my function goes to negative infinity as x approaches positive infinity. So for an odd degree, they're going to be opposites. For an even degree, they're going to be the same. So if you look at quartic functions, that's my x to the fourth. That's my fourth degree. So my degree is back to even. So if you know that your degree is even, you know they should be going in the same direction. So then they go in the sign of the leading coefficient. My leading coefficient is a positive. So that means they should both be going up to positive infinity, which is what this graph shows. So my end behavior, my function approaches positive infinity as x approaches negative infinity, and my function approaches positive infinity again as x approaches positive infinity. Again, all this is saying is that your function is going up as you go left, and your function is going up as you go right. So remember, x to negative infinity is left, x to positive infinity is right. Okay, so then if I look here, I've got an even degree with a negative leading coefficient. So my degree is even with a negative leading coefficient. Okay? So my function is going down to the left, so it's approaching negative infinity as x approaches negative infinity. And then my function on the right is also going down, so it approaches negative infinity as x approaches positive infinity. So again, like I just said, the only thing that's changing problem to problem is that first little sign of am I doing positive infinity or negative infinity. Everything else is the same. Okay? So then if we look, our next one is quintic functions, which is just x to the fifth. So it's an odd degree this one has a positive leading coefficient. So without even looking, an odd degree tells me they're going to go in opposite directions, and the right end behavior is going to go in the direction of the sign of the leading coefficient. Well, this is positive, so my right side should be going to positive infinity, which it is. So I could have a whole lot going on between here, but my end behaviors are predictable just from those two characteristics. So my function is going to approach negative infinity as x approaches negative infinity. And then my function approaches positive infinity as x approaches positive infinity. So it's positive, I should end positive on the right. The left is opposite. So here you can't really see this, but this is y equals negative ax to the 5th power. So I have an odd degree with a negative leading coefficient. So my right end behavior should be going negative, and then it's going in the opposite direction from my left end behavior. So my function goes to positive infinity as x approaches negative infinity on the left, and then my function approaches negative infinity as x approaches positive infinity on the right. So, with all of that, does it matter if you have a 5th degree, a 7th degree, and 11th degree? No. If you can pay attention to odd versus even, then you should be fine. If you have an odd degree, they go in opposite directions. The right side goes in the direction of your leading coefficient. So if you have an odd degree, regardless of what the degree is, if it's a positive leading coefficient, you're going, on the right side is going to positive infinity. The left side should be going to negative infinity. If you have an odd degree and it's a negative leading coefficient, your right side is going down, your left side is going up to positive infinity. Same thing with even. If regardless of what degree it actually is, 2, 4, 6, 8, 10, 20, they're going to go in the same direction. So if your leading coefficient is positive, they're both going to positive infinity. If your leading coefficient is negative, they're both going to negative infinity. That's really the main thing. If you can get that down, then it doesn't matter what function I give you, you should be able to determine what the end behaviors are. Now, let's talk about graphing polynomial functions. When you graph a polynomial function, you want to find the zeros of the function, which are your x-intercepts, using the graphing calculator. Sometimes they're going to be easily seen, sometimes you're going to have to use the feature that I taught y'all a few lessons back, where you have to get the calculator to trace it for you. Your zeros, you can either do what I just said, or you can look in the table where y is equal to 0. You can also tell where a 0 is located when the sign of the y value starts changing, which means that it's crossing from positive to negative or from negative to positive. It's got to cross that x-axis in order to change signs. Here, it's not going to be like quadratic where we specifically did a vertex 2 points above, 2 points below. You are going to have to get as many points as possible to accurately draw that graph. Now, it's going to be different for all of you, but if I cannot tell what your graph and curves look like, you're going to get points taken off. So make sure that you have enough points in your table to show me that curve. It never hurts to do more than you need, just so that you don't get points taken off for that. Now use what you know about your end behaviors to sketch the graph. You're going to state the end behavior, and you're also going to state the domain and range in interval notation. Okay? So here, I've got f of x equals negative x to the 3rd plus x squared plus 3x minus 3. I need to state my zeros, make a table, state the domain and range, and the end behavior. I didn't put that in there, but you do have to do the end behavior. So, we're going to go to the calculator. Okay. Once you get to your graph, you're going to type that function in. Negative x to the 3rd power plus x squared plus 3x minus 3. Okay, so you should be able to recognize it's an odd degree with a negative leading coefficient. So it should be going opposite directions. My right end is going to negative infinity. My left end is going to positive infinity. So in order to find the zeros, now it looks like this one is very clear, but this one is between 2 points. So remember that you can go to menu 6. I'm trying to find my 0. So I'm going to hit enter. Menu 6, enter. So if you need to do that, menu 6, enter. And remember that you're going from the left side of the 0 to the right side. Now I'm going to move this over so I can see. Now that's negative 1.73. I'm just going to put a negative 1.70. Okay. Now this looks like it should be 1, 0, but I'm going to just make sure it is 1, 0. And then I'm going to do my third one the same way, menu 6, enter. And that is a positive 1.73, so I'm just going to do a positive 1.70. So those are my zeros. You must list them before you do your table. Okay? So then I need to create my table. So I'm going to go, if you look, you need to have enough on the left of that 0, enough here to make that curve, and enough here. Now I don't need every single point between these, but you need enough, okay? So I'm going to go to Control T, and I'm going to at least go to a negative 2, okay? So if I know that this is a negative 1.7, I need at least negative 2. Now if I go to negative 3, 24 is obviously not going to fit on my graph. So negative 2, 3 will be my first point. Then I'm going to include my negative 1.70 because that is a 0. I'm going to include that in my table also. Negative 1, negative 4, 0, negative 3, 1, 0. Now, it jumped straight to a 2. Now, I know that 1.70 is there also. Now, if you wanted numbers in between that, you could change the table, menu to edit table settings. My table step, I could change that. If you wanted to change it to 0.1, you could. I'm not going to for right now. So, but that is also how you could do it. Okay. Now I'm just gonna put my 1.70. So I've got both of those right next to each other. And then I'm going to include 2, negative 1. Now if I need to keep going, I can. 3, negative 12, but that's going to go off my graph. So I'm going to go back and look at this. See how it goes a little bit above those? You need to actually make sure that you resemble that. Now it doesn't go quite to 1, so if you draw a big curve on your graph on your paper, that shouldn't necessarily do that. Like if you crossed it up to 1, yes, you will get points off because that's not the values. Okay, so I've got negative 2, 3, negative 1.7, 0, negative 1, negative 4, 0, negative 3, 1, 0, 1.70, and 2, negative 1. Okay, so we know that it was an odd degree, so we know that it should be going here. And then we come back up, we do a little curve, and then come back down. Okay? Now, This probably should be a little bit closer because I know that comes down to 12, but that's okay. That comes down to negative 12 at 3, but that's okay. I'm mainly going to be looking here. Okay, now it's hard to freehand this. I get that. Mine wasn't perfect. It's not like it's linear and you can use a ruler, but I'm going to look at your curves and if they're generally, what the graph should look like. Okay, so once I draw that, I need to state the end behavior. So my end behavior, okay, I'm going to do it as x goes to negative infinity and as x goes to positive infinity. So my end behavior, my function goes and approaches to positive infinity as x approaches negative infinity, meaning going to the left, and my function approaches negative infinity as x approaches positive infinity to the right. So that's my end behavior. And then I'm going to do my domain and my range. So my domain, I'm going indefinitely to the left, indefinitely to the right. I'm going to positive and negative infinity. So that is going to be my domain. My range from bottom to top happens to be the same. I'm going from negative infinity to positive infinity. And you will notice for odd functions, that's typically what you're going to get. It's when you have even degrees that it's going to change a little bit. But when they're going opposite directions, you're going to positive and negative infinity regardless. Okay, so let's look at this last example. Okay, you've got x to the fourth minus x to the third minus 4x squared plus 4. So I'm going to go to my calculator and I'm just going to doc B it, make it easy to clear it. And I'm going to type that function in. X to the fourth minus x to the third minus 4x squared plus 4. Okay, so now I really got some curves going on, but I see that it's an even degree. It's a fourth degree, and it's a positive leading coefficient because it's positive 1, so they should be going in the positive infinity direction. So I have, I'm going to have to accurately put those points in the table, but I only have 2 zeros, meaning the other 2 are imaginary. I only have 2 real zeros. Okay, so my zeros, I can tell that this one is 1, 0. Again, if you want to double check, you can. This one's in between, so I'm going to use my menu 6, enter. And that gives me 2.38. I'm going to round that to 2.4. I'm going to round to the nearest tenth. Okay, so those are my zeros. Then I'm going to build my table. Okay. So if I do Control T, I'm going to go, if I can look negative 212, I'm going to go ahead and include that this time because of what the graph looks like. Then I'm going to have negative 1, 2. 0, 4. And then I've got 1, 0, which is my 0. I have 2, negative 4. Now, sorry, that went blank. So here, it jumps straight to 322. So this is where I'm going to change my table. I'm going to go to menu, 2, and then 5. So if you need to write that down, menu, 2, 5 while you have the table up. Okay, so I'm going to change my table step to 0.2. Okay, it can be whatever you want. I'm just going to do that for right now so that I can see. So I'm over at 2, -4. So at 2.2, I had -2.6. We know that at 2.4, it's a 0. So this is 0.3, but it's 0. And then 2.6 will give me 5.1. And then if I do another one, 2.8 would give me 12.2. Okay, I understand that this is going to throw some of y'all off, but that is what it was calculated, because technically it's 2.380, and we just rounded that to the tenths place. So 2.4 technically is 0.3, but we're going to round it, so it's good. If you really want to put the 2.38, that's fine, but I'm going to round them to the nearest tenths place. So if I keep looking at this, I should have a curve here, a curve around the y-intercept, and a curve below here. Okay? So I'm going to look and plot the points. -212 would be up here. -1, 2, 0, 4, 1, 0, 2, -4, 2.2, -2.6, 2.40, 2.6, 5.1, and then 2.8 would be right at like 12.2. Okay, so you want to make sure, I'm going to flip this over, get rid of the table. Look at what's happening here. You want to come and then curve it up, curve it back down, curve it back up. Okay? So I'm just going to if you have to do bits and pieces to make it look neat, then do that. Make it look as best as you can. Obviously mine's not the best either, so I get it. But make it look something similar to what it should. Okay? Now, just a note that an even degree function may or may not intersect the x-axis, just like we just had. Okay, that was an even function that only had 2 x-intercepts. So that means if it doesn't intersect the x-axis, its zeros are imaginary zeros. An odd degree, though, will always cross the x-axis at least once. Okay, so at least one time you will get that. Now, on your worksheet, you will have sections where you are given a graph and you have to describe the end behavior. You have a section where I give you a function without a graph. You have to describe the end behavior. So the section in the notes that has this chart is the best thing for you as far as end behaviors. The rest, graphing, just make sure you have enough. Now, I didn't do the end behavior in domain and range for that graph, so let me go ahead and do that before I stop. I was getting ahead of myself thinking. So here, my end behavior, okay, my function approaches the positive infinity. both times, as x goes left and as x goes right. So it approaches positive infinity as x approaches negative infinity, and then my function approaches positive infinity again as x approaches positive infinity. So there's my end behavior. Now, I told you with an odd degree function, your domain and range are typically negative infinity to positive infinity for both. Here, my domain, it's going from left to right, you're going from negative infinity to positive infinity. So pretty much your domain's going to be the same every time. Your range is going to change if you have an even function like this. Because though it's going to positive infinity, I actually have a cutoff right here. This is my lowest point. So if my graph is going upward, I'm going to look at my lowest point. That's at -4. So I'm going from -4 to positive infinity. Okay, so that would be my range. Now, what if my graph was opening down? If my graph was opening down, regardless of what it looked like, okay, I would have a maximum, and that would be my range. So say hypothetically that was at 10, okay, my domain would still be negative infinity to positive infinity. It's not going to change. My range would go, it's going down, so it would go from negative infinity and cut off at the max of 10. So hypothetically, that's what your range would look like. Okay? So you should have enough now to do your worksheet. Next class, y'all will have review day, and then you'll have your test. So if you have any questions, let me know, email me, and then that's your last lesson for the unit before we do midterms.